Okay, fine, let's start. Fine. Yesterday, I think we looked at some introduction to Java. Fine. Quick review on that. Right? Yeah. So, yeah, we started with the question. Yeah, what was the question? First question. What is Java? So, yeah, what is Java now? What is Java?
Java is a programming language.
Fine. So, yeah, two things, right? Java is programming language.
Java is platform.
And for this programming language, there are specifications. They are managed as. So, if you want to know the specifications, from where you will get it? Look for Java language specifications. So, JLS. You can just search JLS. You'll get jls.pdf. Fine. Look for the latest version, that is 8. Fine. So, that will give you the all specifications for a Java language. Fine. So, one aspect of Java is it's a programming language. Right? So it's a, but it's of course it's a object oriented programming language. Okay. What was the other thing about Java? So this is one. Java is also name of a platform. Two are separate. Okay. One is language, other is Java is also a platform. Fine. So Java is a platform. So we have a platform with the name of Java, and for this we have a JVM specifications. And you can search for JVM specifications and you should be able to get the specification for the platform. So two separate specifications managed. Okay. Fine. So language is one, specification platform is another. And for this platform, it's not only that we have Java language, there are other languages to work on that same platform called Java. Okay. So for the Java platform, what are the other languages? A few of them. For example, we have Jython, we have JRuby, Scala, Clojure. And these are just some of them. And there are lots of other languages available for the Java platform. Yeah. Okay, fine. We'll be looking at the Java programming language as well as, yes, we'll understand the platform. Okay, but thing need to be clear that the two are separate. There's one language and the other thing is a platform. And important thing about the Java programming language, what's the relation about the language? How it was marketed as a platform independent language. What exactly was meant by saying it is platform independent?
We created it
Yeah.
in one platform and running any platform. Like
Your native platform, fine, we have a difference, right? Java is also name of a platform.
yes.
And the Java language is meant to work on the Java platform. Okay, fine. Because Java language is meant to work on the Java platform. If I compare with other languages like C, your process would be like this. You write a code in C, get it compiled, get an executable. Fine, you get a executable. So when you compile, you get an executable, right? Compile and link it. Fine. This executable is created for a specific platform. Fine. If you compile on Windows, yes, the executable generated would work on the Windows platform. Fine. Whereas, yes, what we have here, if we got a Java code, when we compile, what you get is known as Java bytecode. Okay. And this Java bytecode is meant to work on the Java platform. It's not the platform where you compile, independent of where you compile. You may compile the same Java code on Windows platform or on Linux platform. The output is the same set of Java bytecode. Fine. This Java bytecode is something which would work on the Java platform. This would work only on the platform where you compile. So this compilation is independent of the platform where you compile, the output of compilation here. And so when you compile here, and we have the JVM specification, right? So the JVM specification is basically saying it's a machine. Java is a machine. Okay, so this Java bytecode basically has all the according to that specifications, this has the all the instructions. Fine? There's a full instruction set for the JVM. When you look at JVM, you'll get the opcodes, operands, and all those things. Fine? So we have that specifications. So this Java bytecode would work only on the Java platform. So what we have actually at runtime is we need a we have a JVM interpreter for the platform on which you would like to execute it. So here is a fine, you'll call it as a native platform, fine, like Linux and Windows, that's a native platform. So you would have a JVM interpreter for your platform. So it would so it's compiled and then interpreted at runtime. Java is interpreted at runtime. Fine. The Java bytecode which is generated is independent, is for Java platform. Fine. And then for execution purpose, each instruction of JVM has to be translated into native platform and then executed. So that is being done. But yes, one would believe this is slow, but it actually is not slow because of so many years of research whatever has gone into this interpreter, and there is a lot of effort which has been gone into this, and therefore it doesn't turn out to be like, oh, it's a slow thing, right? Though it's an interpreter. Okay, whereas this would directly work on your platform, right? Whatever is the platform for which on which you compile, and so that's the difference between Java and your languages like C and any other things, right? Locally compiled. So this was one, right? Yeah. Then we saw that applet. Fine. We saw something about applet. And what we had seen yesterday was, yes, we say applet brought Java into limelight. Fine. We could understand how Java is used on what exactly is applet. Fine. We had seen that aspect, right? Applet is nothing but Java special kind of a Java compile code which would work inside a browser. Okay, it can work inside a browser. Fine. And the pioneering idea about applet was, because this was in 1995. Fine. This was yeah. Okay. There are a few things we had seen yesterday. Sun Microsystems. Fine. Sun Microsystems started the project for Java in 1991. Okay, at that time they called it as Project Green. Fine. And yeah, who's the scientist there? James Gosling. He was the scientist who led the team for that project, and he is now known as father of Java. Okay, fine. And the applet was one thing which actually triggered Java, and like otherwise no one was looking at Java. Fine. So they did a pioneering thing with the help of applet, and the date on which they demonstrated, Sun Microsystems demonstrated applet to work inside a browser on 23rd of May 1995. So that's the birth date for Java. Okay, fine. 23rd May 1995, that's known as the birth date for Java. Okay. Yeah, what was demonstrated? See, we have Java bytecode being independent of platform. What is needed is a JVM interpreter must be available, fine, to use a Java bytecode. Fine. So what was demonstrated at that time, like like you have images, you have a HTML page which you will see in a browser. So as part of a HTML page, if you put a image tag, you will receive the image from the server and it would be shown on your machine. Okay, so similarly what they demonstrated was, okay, like you have an image tag, they added a tag for applet and said, okay, we can have a Java bytecode which is on the server, it's managed on the server, fine, there's only one copy of it, and it can come to the client machine along with the HTML, just the way a image would come. Okay, and it would, so in your browser, inside the browser, what is needed is you need a JVM interpreter to be available. So once you have a JVM interpreter, independent of the platform, independent of which browser you use, you have your client program in the form of an applet working inside your machine. Okay, so that was a pioneering idea in those days. This was 1995. And that's why Java means, oh, it's a language for the internet. That's how it was, like it was shown. But basically Java is a general purpose object oriented programming language. Fine, it's not just, it's used for the, but yes, it was brought into limelight because of the applet. Fine. And therefore, some of the old books, if you look at them, you'll find that they would start with the first chapter, they will just introduce applets first. Okay, so fine. Anyway, this was history of Java, and then what was the next thing we saw?
Example.
We saw the example. Okay, fine. We started looking at what is object-oriented programming. Fine, and one of the statement we made was object-oriented way. See, we use programming to solve problems, right? So object-oriented way of solving problems is closer to the real world way of solving problems. Fine, it's closer to the real world way of solving problems. In real world, problems are solved by collaboration. And there's a lot of interaction which has to take place for solving a problem. And for that, yes, we had seen a small example, and just quickly go through that example. Okay, fine. We took as a problem that yes, we have a friend in Kolkata and we would like to send flowers to our friend in Kolkata. Fine, and for that, in real world, how we go about it. So one of the possible ways was that yes, we go to a local florist shop somewhere in Baroda. Fine, flowers is not something which can be couriered. Fine, you buy it and courier it, but still we go to a local florist shop. So for example, we said, okay, we go to a local florist here and we have someone called JK Florist. So we go to JK Florist, but we have an interaction with him. So what is the interaction that we have with him? So we interact and we'll say send flowers. Fine, we just say send flowers, and we say send flowers. This is the instruction, but for this instruction there are some information to be supplied whenever we have this instruction. Fine, so and this is our verb basically, you're saying send flowers, but then associated with this you have to specify the name and address where you want it to be sent, what are the type of flowers, the quantity. Fine, such things you can have more such information, but fine, basic things would be this much. That's your interaction with the JK Florist. Once you have this interaction with JK Florist, what will JK Florist do? Always whenever someone says send flowers and gives me the name and address, the first thing I do is look at the address. Is it a local address? If it's not a local address, then oh, what's the city, what's the destination? Oh, that's a destination town. I have a diary with me where I manage all my contacts for other towns. Fine, and then I'll locate someone in Kolkata. So for example, I locate that yes, I found someone in Kolkata called KK Florist, let's say. Oops. And so let's say we have KK Florist in Kolkata. So fine, he would. So now what JK Florist does? Locates us, and he has an interaction again with KK Florist. And what would be the interaction? He'll repeat the same interaction. Send flowers with KK Florist. Fine. When KK Florist receives this interaction, yeah, he'll again look at the address, and now he says, yes, it's a local address. It's not a, right, because he's in the same town. So it's in the same town. Now the next thing he looks at is the type of flowers. Fine. And for this type of flowers, he again has to have a diary where he finds out, okay, this type of flowers, who's the flower producer? Fine. So he interacts with a flower producer. Fine. There's some, you can assume there's some name for him, and he interacts with the flower producer. What is the interaction now? He says, get flowers. Fine. Where he'll specify the type of flowers and the quantity, and he will receive the flowers of the flower producer. Now here's the flowers from the flower producer. He's got the name and address, and then he interacts with a delivery boy. Fine. There is some delivery boy with whom he will interact. What is the interaction? Deliver. Fine. With delivery boy, the interaction would be deliver, and he'll specify name, address, and the flowers, and then this goes and delivers to your friend. Right. So to solve a problem, there's a lot of interaction taking place between different entities. Fine. Have JK Florist, KK Florist. You can assume some name here. Fine. So there's some person who's a flower producer. There's some person who's a delivery boy. Fine. I've just said FP, but understand there has to be some name. Fine. There has to be some name here. Yeah. Okay. And then yeah. Then what did we look at next? Here. We went to JK Florist and said send flowers. He understands send flowers. Why? Why does JK Florist understand send flowers? We could have gone to a grocer and said send flowers. He won't understand. What's the reason why he understands? Because he is a florist. Find the type. Fine. Okay. We have something called class. He is of class JK Florist and KK Florist both. Fine. Let me take KK Florist here. KK Florist is of type florist. The type is florist. It's simply a definition. Data type. And we call it as an object oriented term. So we use the term class. Fine. We have a class called florist. What is KK Florist? What is JK Florist? What is KK Florist? They are objects. Florist is the type. It's simply a specification. It's simply some definition. But actual object, they are the KK Florist and the JK Florist. The type is florist. There's someone here. The type is flower producer. There's someone here. That's an object. But the type is delivery boy. Fine. Each type understands a set of interactions. You can have a particular kind of interaction with a particular data type. Fine. It's a type. See, if it's a int, right? If the type is int, what is it that I can do? I can have increment, decrement, I can have or arithmetic. Right? It all depends on type, that what can be done with it. Fine, what interactions you can have. Okay, interaction, operators, they're one and the same. They're all synonymous. Okay, fine. If it's int, oh, I can do all those things. If it's a string, oh, I'll be able to do a different set of things. It all depends on the type. So that's the definition. But then we have actual objects, the values of that particular type. Fine. Okay, so that's the object. Fine. So we had yesterday what we had written was object is an instance of a class. Class is a data type, object is some actual occurrence of actual instance of that type. Fine. With the type, what is linked? So for example, yes, JK florist, what was linked with them? What is linked with florist? Because he's a florist, therefore send flowers. Because he's a florist, and therefore we have send flowers available with as an interaction for JK florist. Okay, florist is one thing. Yeah, you can go and say send flowers to KK florist. Also, he understands that. But you also have another kind of interaction, which is like accept this payment, accept payment, get me a bill, fine, because he's giving service. But that's something which is not just because he's a florist, but because he's a shopkeeper. And all shopkeepers understand accept payment. And all shopkeepers will understand all those commercial things. And so there's a specific set of instructions. But one thing what we know about florist is all florists are shopkeepers. Florist is a shopkeeper. Okay, so there's a bigger thing here called shopkeeper. Okay, fine. Florist is a shopkeeper. Any interaction available for shopkeeper is definitely known to the florist, is available for florist. Okay, fine. Okay, and then still bigger, we can go and say to KK florist, how are you? He understands how are you also. But that's an interaction which you can have with all humans. Fine. So there's a still bigger class called human. Actually, you can start with human, right? So you can say, okay, we have a class or a type called human. Humans understand a particular set of interactions. They are defined for all humans. Within humans, we have a specialization called shopkeeper. If he is a shopkeeper, he will also understand few other things. Fine, but anything which is available for humans is definitely available as an interaction for shopkeeper. This is what is inheritance. Fine, you have a type called human and a subtype, a specialization within them called shopkeeper. Fine, same way from shopkeeper we have a further specialization called florist. Okay, fine, and that's how the interactions, the kind of interaction. So this is what we also wrote yesterday was a subclass has more functionality compared to superclass. Superclass has a particular set of functionality. Subclass will always have that because it is inheriting, and then it can add more things to it. Fine. So that was inheritance. Fine. So yes, when we talk of object-oriented programming, we have inheritance. Fine. Another aspect before talking of, whenever someone talks of object-oriented programming, even before inheritance or any such things, we have something called abstraction. Yeah, what is abstraction? Fine, I didn't discuss, I think, yesterday. What is abstraction? What we did yesterday, first thing what we did was we decided this kind of interaction. We identified. What did we identify? That we have a type called florist. Fine. We identified that there is a type, there's going to be a type called florist, and for florist, there's going to be an interaction called send flowers. See, this process of identification of the types or the classes here, fine, and what kind of operations they would each be having. This is what we call as abstraction. So we have that process of abstraction. That's how we are able to realize all the types that will be needed in solving your problem. So look at a problem. and identify the types. Okay, that's what is abstraction. Fine, identifying what types will be there, what interactions will be necessary. Clear? Fine. In order to solve my problem, that's what is needed, right? Okay. See, the difference in object-oriented programming was, when we talk of object-oriented programming, we have programmer-defined types. Classes are nothing but programmer-defined types. Oh, we did have programmer-defined types even in C language, like we had structures, struct, right? Type def. That would define that's also a programmer-defined type. But then what was missing there? Interactions, the operators, and we didn't have the flexibility of giving what operations will be there for this type. You just say this is a type, its type is not simply a structure. Fine, the type associated with the type are the operations which can be performed with that type. If you have something of this type, what can be done? Okay, that needs to be defined, and that's where the object-oriented programming languages made a difference, right? And we had seen the progress of the programming languages, low-level languages like assembly language, machine language. What was there? The data types were fixed by the language. We can't even have our new data types we want, and even the operations for the types were defined by the language. You have a fixed instruction set, only you use those things. Fine, to write your code. And then higher level language like C, you can create your own data types, but for those new data types, you can't define your own operations. Fine. Operators were fixed by the language. Object-oriented programming says, okay, you define your types, fine, like you define a class, and you decide what operations you would like to have for that particular type. Fine. So that's where the difference was, right? Clear? So you can associate now, right? This data type and operations. Fine. See, we say function, we say methods. Fine. We use such terms for operations. Fine. So just think they are synonymous to operator. You know, when you say operator, operator has operands. Fine. The operator is simply a symbol, like plus you are saying is my symbol, but you have operands for it. Same way, you have a function which is the name, it's like the operator, it's like the symbol. The parameters to that, they are like the operands. And think of this as operands. Fine. And when we call a function, it results in a value, the expression type. When we apply an operator, it results in an expression again. Fine. The return type for the method is like the expression type. Fine. So they're almost exactly quite similar things. Okay. So for a type, we have a set of operators available. Same way for a class, we have a set of, we call them as methods, those interactions. And in Java, we will call them as methods. Right? We haven't yet started with Java yet. Okay. Yeah. Okay. So inheritance was one thing. Fine. We saw that in subtyping from a type, derive a new type. Fine. Which would inherit all the things, all the basically we are more interested in the operations, right? All the operations would be inherited, plus additional operations can also be added, fine, in a subtype. Okay, next thing was data encapsulation. Yeah, what is in that real world problem, where was the data encapsulation? Yeah,
for the data
for the diary, he was looking at the diary, right? The florist, the diary can't be publicly available, right? And diary is nothing but a data structure, fine, where he is managing, fine. So that diary cannot be used by anyone, right? It has to be with him only, fine. If it was available to all, or anyone can go and make any kind of entries in that diary, it would be meaningless, fine. Fine, in the real world also we understand, right? The diary would be managed by that person only. The florist only will manage his diary. Fine, he'll not allow anyone to go and touch the diary and say, okay, yeah, if you want any information, you can ask him, he can give it to you from that diary. But yeah, you need to actually have a interaction with the florist. You don't directly touch the data structure which is used by the florist. Okay. Fine. So data encapsulation. Normally, it's like this. You have a data part associated in your object. You have some data structures available, but when you want to have them, you have to interact by using some methods. Call a method. That method can only touch the data structure. And so we say encapsulation. And this is the data part is encapsulated with the code, and you have the code here. And you have a data here. Okay, fine. And then next term, yeah, we had polymorphism. Okay, polymorphism involved. Yeah, related to polymorphism, there are two terms. I'm directly jumping to the programming terminologies used here. That basically many types of polymorphisms, but the common terminologies in programming which we use is we have something called overloading and overriding. Okay, fine. We have overloading and overriding. Overloading refers to, okay, let's see this overloading. Fine, I think this is where we were, right, yesterday. Okay, so as an example for overloading, okay, let's think of another kind of an object. Okay, so there used to be those things like plotters. You may not have seen those things, but you have printers, and we have printers and plotters. The thing called plotters, and still I think mechanical people, they would still be using mechanical engineering. They might be having robots with to draw some things. So we have something called plotter. So let's assume that we got some plotter, right? So what is the interaction we can have with the plotter? Yeah, so it can be to draw certain things. So you might have an instruction called draw line. So when you say draw line, yeah, what would you specify? Starting point from this point to this point. A point may be given as x and y coordinates, and you give 2 points from this point to this point. Draw a line from here to here. Okay, like draw a line. Someone says, I also want to draw a circle. So if someone says draw a circle, yeah, what's the input? You'll give a center point, you'll give a radius. Fine. So you have a draw circle like this. Now there's someone who's got 3 points in a plane. There's a unique circle which goes through it, and he wants to draw a circle. He knows 3 points. So what will he do? Oh, there's a standard formula. Fine, there's some standard way. By using those 3 points, he can derive the center point and radius. Fine. From those 3 points, center point and radius can be derived. So he will have to go through the derivation point, and then he will use then only he'll be able to interact with the plotter and say draw a circle. And if something goes wrong, the plotter is to be blamed. It's not his calculation. The idea here is that yes, there are standard things, right? So what he could have done, he could have said, okay, you can draw a circle. To draw a circle, you can give me center point and radius, or you can draw a circle even by giving me 3 points. I'm doing the same thing. I'm still draw a circle. Fine. But since there is a standard way of deriving the center point and radius from 3 points, okay, you might make a mistake Let me have one standard way of doing it. Fine. Okay. So you don't have to do that calculation part, making it more convenient for you. Fine. So what we have here is we have the same name. It's a draw circle. Basically, it's doing the same thing. Both are about drawing a circle. The kind of inputs are different. Okay. Fine. So this is within your class, within a particular type. Okay, it's offering more than one kind of inputs. It's allowing you two different kinds of inputs to do the same thing. Yeah, drawing circle with different sets of inputs. And so this is example of overloading. Okay, fine. Now for overriding, okay, if we talk about overriding, for overriding we'll have to look at a different kind of an example. Okay, basically I'll tell you one thing. As far as overriding is concerned, more examples will be when we start coding in Java, right? At this moment, you can just try to understand, okay, the concept. Fine. The idea here is in overriding, as an example, we can talk about what we did with Florist. Okay, in that example, we said there was an interaction called "How are you," which can be there with all humans. And we can say "How are you" with all humans. But of course, when someone says "How are you" with all humans, there is one normal behavior which is defined for "How are you." If there is someone saying "How are you," this is how you should be reacting to it. That's available for humans. Okay. Now you go to a shopkeeper and say "How are you?" He is going to be extra friendly because he is looking at you as a customer. Okay, he is looking at you as a customer and is going to be extra friendly. It's not the same behavior as is normally defined for humans. There is a change in, fine. The idea here is we have for humans, okay, for humans, we have a particular behavior, it works in a particular manner, but then we have a subtype called shopkeeper, fine, which has that, it's not saying I don't understand how are you, it's not going to say, because it's a human, it has to understand how are you, but the way it works is different from what is normal. We say this is an exception to the rule. Human defines the rules, fine, general rules. Specialization, fine, when there is a specialization, he adds more functionality that we understand. But what can also happen there is some functionality can change, the way it works, that can change. Okay, that's what we call as overriding. It's an exception to the rule. Okay, it's an exception to the rule. Fine, once when we start the coding part, right, there you will be able to see what exactly is meant by overriding. But this is just try to understand the concept here. Fine, you'll have some things. General rule is one, but then there are exceptions to it. Okay, fine. Another example for exceptions could be where we have a class called mammal. All mammals have offspring, but we have a kind of mammal called platypus who lays eggs. An exception to the rule. That's where we call as overriding. It's not giving the same behavior as was generally defined. See, whatever is your superclass is the general behavior. That defines the general part. When you derive a class, it's a specialization. And there you can have some things, fine, which works differently. It's not saying I won't work. Fine, it can't say no, I can't, you can't stop a behavior. Fine, you can't say no, I don't understand how are you. Fine. But yes, the way it would work, Fine, whatever reaction that should come may be different. Fine, it changes. Fine, because it's of a particular class. Okay, and this is what is overriding. And so when we talk of polymorphism, yeah, there are different types of polymorphism. These are two common things which we will find in programming: overloading and overriding. Fine, so this was about object oriented programming. Fine, some introduction what is object oriented programming, the common terminologies related to object oriented programming which you should always know. Fine, they are all these, right? And we have I'll just put those terms. What is object, the relation between what is object, what is a class, then inheritance, abstraction, encapsulation, data encapsulation, or even we call it as data hiding also, and that term is also used, and polymorphism. Okay, fine, clear on this? So any questions now related to this? We'll then switch to writing our code in Java now. But any questions before that on related to object oriented programming? And other important thing was Java is a language, Java is a platform. Right? Two things. That distinction must be clear. Okay, fine, we'll proceed then. Okay. Okay, so fine. So let's start by writing our, how do we write applications in Java? Fine. Okay, so our aim is to have an application written in Java, fine. And what's the first application which we normally write? What was the first application you did in C language? Hello? Fine. Hello world? Okay, so fine. We would like to have our code in Java to write hello world on the standard output. Fine. Printing hello world on the standard output. Fine. So yeah, so before exactly jumping into creating a code for showing hello world, let's try to look at, yes, to do this in C language, what did we write? Yeah, what did we do in C language for getting hello world?
First,
Yeah,
insert the header files.
you have a file in C, .c file. Yes, in that file, what did you write? You have to write a function. The function's name is main. And you need to write a function called main. Okay, fine. So main function is basically your application. Someone has to call the main function. See, main function has to be invoked. Functions have to be invoked. Okay, fine. So fine. When you give your command, you compiled and everything was done. When you give the command, it actually invoked the main function. Fine. Calling that, giving that command would simply invoke the main function. The execution of whatever is written inside main would then start. Okay. Even for Java, the application is written in a method called main. Yeah. Applications. Fine. Application is written in a method called main, but there are a few requirements about this main. Okay, fine. Application is nothing but method main. Fine. Now, where do you write? In a file? Okay, you'll write your code in a file. In this case, for Java, your code has to be written in a file with the extension of .java. Fine, the extension has to be .java only. You can't have any other extension. Okay, fine. Now, okay, in a Java file, what is it that we can have? Okay, in a Java file, we use a Java file only for 4 kinds of things. Java is only 4 things. There are only 4 things in a Java file. Entire Java is about creating only, it allows you to create only 4 kinds of things. And those 4 things are, in a Java file you can either define a class. So one is, you can define a class. Fine. You can define an interface. Fine, Java file. You can define a class, you can define an interface, or you can define an enum. Okay, and the fourth thing, you can define a annotation. A Java file is only capable of these 4 things. Entire Java is this. If you say, okay, what is Java file? Or this only. There's nothing else you can have in a Java file. Oh, where is my application then? Okay, enum is basically similar to a class. It's similar to a class. It's a very special kind of a class. A class, we understand. What would be a class? A class would be giving structure and operations. So this also says structure and operations. Fine. There is also about structure and a set of operations which can be performed. The difference between enum and class would be, when you have a class, there's a lot of things which we can do. You can create object of that class anytime you want, right? But with the enums, no. It has a prefabricated objects. It's a class where we have fixed objects. These only, nothing else. And I'll put it as prefabricated objects. We fabricate the objects when you define it. See, when you said you are defining a class, what are you doing?
You can use all the options.
What are we doing when we are defining a class? We are creating a new type. It's a definition. There's no object in it. Okay, there's no object. I'm just saying, okay, this is my class definition. Fine, it's about a type. See, int is a data type which is predefined. It's from the language. The language specification says what can be done with the int. When you define a class, you are putting all that specification. If there will be anything of this type, this is what can be done. This is how it should look like. See, for a specification for int would say, oh, int is going to be so many bits. Fine. With int you can do all these arithmetic. With int you can do the shift operations. With int you can do all this, right? That's what the specification is. You are defining a class, you are only doing that. You are giving a structure. It was saying this 32 bits. Oh, you are saying, oh, this requires so and so structure. I have a particular structure. Along with the structure, you are also giving what operations will be allowed. Class. Okay, fine. In case of enum, since has a difference, it's almost the same. It's almost the same, but in case of enum, it's not only the specification, it also says these are the objects we are having. That's it. There's no other object. For this type, these are the only objects you have. It's also a type. All these 4 are data types. If anything is a data type, what can be done? Declare variables. You can declare variables. That's the first thing we can do with the type. You can have a variable of any type. So if I define any of these four types of things, I should be able to declare variables of the four types. Fine. Okay, fine, more about it later. Fine. Let's first move into defining our first Java application. We want to write our Java application. Okay, but first thing, in a Java file, four things only. Fine, what is possible? Four kinds of things. Okay, so where is our application then? So as far as application is concerned, the application is nothing but it is a method. We say it's a method, but method is part of the method which is needed for an application is a special type of method. It's nothing but a method called main. That's one thing. But this method has to have return type of void. Name of the method was main. Okay, you can have you can have any other method name also appearing inside a class definition, interface definition, all those things, definitions were there, and you can have methods there. Okay, return type void. The main method has to be a public method, and it has to be static also. It has to be, and you can interchange public and static. These are modifiers for my method. Method basically is nothing but a block, processing block, which would require inputs and can give output, single output. That's what is return type, to give what a kind of output this processing block will have, and inputs with the help of a parameter. So this main requires an input. The application, fine, the application main requires an input. That input is of type string array. So you can say string array, give a variable parameter name, a or args or anything, fine. More commonly people put a variable name as args, fine, or you can just say a or b or c or anything. It's just a parameter name. Fine. So this is what an application is. Fine. You can have your application block, fine, and you can write your code here. And that's an application. Okay. Now, method main, yeah, what we can do, this can be embedded inside. See, a Java file can have only these four things. There's no place for a method. Fine, in C, we'll write a function straight away. No. In Java, what you can write is only those four items. Okay, fine. And this main can go inside a class. Fine, you can have main inside the enum also. Enum is also similar to a class. Okay, now there's a difference which came from Java 8 onwards. Okay. Fine, something which was not possible earlier from Java 8, what has changed, there's a lot of change which has happened from Java 8. What has changed here is even interface can have this main. Why main was not allowed earlier in interface was because of the nature. It wasn't that main was not allowed. You could have a method called main, method name main, but we could not have static methods. Static methods were not allowed in interface, which has now been allowed from Java 8. Okay, static methods not allowed in annotations. Static methods not allowed in annotation. So to write our application, we got three choices. Fine. You may define a class, you may define an interface, or you may define a enum and put the main there. Clear? Main could be put inside any of those three things. Okay. Fine. Now, you have a habit of what? Looking at writing a C code or in any other programming language, you write your code and then you would just compile. So you have a single file, you compile the file and you get an output which is a executable, and then you run that executable. Fine. Object oriented programming, as I mentioned, is more about data types. It's more about data types. These four things which we are looking at, class, interface, enum and annotation, they are data types. They are simply data types. Fine. Here we have the flexibility of creating our types. Fine. Creating a type and then what? You would like to distribute your type or not? Oh, I have defined a new data type. Oh, let this be known to others. I would like to distribute the data type. Clear? I would like to give my data type to others. Fine. Okay, you created a type called circle. Oh, let me have that circle given to someone else. Fine, the type circle. Okay, so that's possible. When you compile, okay, when you compile, the output of compilation, what we say is Java bytecode, is nothing but one of those four kinds of definitions. The output extension is dot class. Okay, I think what I'll do is I'll first let's write a simple application. Fine, and we'll see what exactly the compiler is going to do. So let me try to assume that I'm writing in a file called hello.java. Let's open up a file called hello.java, and in this file let's have the content going like this. Okay, so that's my hello.java, which is my file here. Oops. Fine, so that's a file, and the content of the file, let me say I want to have a class definition. To define a class, the most simplest thing can be use the keyword class and give the name of the class. So I would like to give the name of the class as hello world. Okay, and then start the definition. I'm giving bare minimum things. Fine. Okay, so I'm saying, okay, class hello world. So I want to define a class called hello world. In this, I'm straight away going and putting my application. There can be other things also in a class definition. Fine, but at this moment, we are just simply putting our application. So application requires that it should be public and static. The method has to be public and static. The return type has to be void. Name has to be main. Parameter should be of type string array. Okay, some parameter name a, let me choose. Okay, and I start by open the block for the application for the method here, and in this, yeah, we use what, printf in case of C. So let's put, now it's object oriented, so we'll say system.out. Basically this is an object which represents the standard output. And system.out is nothing but an object which represents the standard output, and with this object we would like to have an interaction called printf. Fine, we're asking it to do a printf. Okay, printf and a string. The string is hello world \n. Okay, single instruction, end of the application. Fine, and I can have end of my class definition. Okay, right, so this is what we can have as our initial content of the Java file. Hello.java, that's a file containing this kind of a definition. Okay, now how do we compile this? So once you have done this, you can go to the command line and use the compiler to compile this. For compilation, the command is javac. And name of the file, what is the file? Hello.java. Yeah, we have javac hello.java. When I compile, I'll get a output, compiled code. The compiled code is going to be in a file with the extension of dot class. What's going to be the file name?
hello.class.
You expect it to be hello.class. It's going to create hello world.class.
Yes, class.
The type, a new type is available in a compiled form. For every class definition, for every interface definition, enum or annotation, anything which has been defined anywhere, there is going to be a dot class file, separate dot class file for each. Every definition, every class definition here has its own independent file. Okay, what is string here? Name of a class. What is system here? Again, name of a class. So understand one thing, there is somewhere system.class in the library. It may not be available straight away as a class file, but yes, in the form of an archived file, like you have a zip file, there is an archived file. So inside that, but there is definitely a string.class. There's definitely a system.class because these are classes. Fine. There is some there is an interface. Okay, if there is an interface, or there is a separate dot class file even for the interface. Every data type which you are defining, 4 things you define, and for each of those 4 types of things, you got class file. When you compile, there is a class file generated for it. Here, independent class file is created. Of course, that class may depend on other classes. For example, what is this hello world dependent on? What does hello world depend on? 2 things at least. Main is the content, but it uses 2 other things. It needs string class and it also needs the system class. And if you look at string class, maybe it also dependent on other classes. See, those classes must be available to it. Clear? At the time of compilation as well as at the time of execution. Okay, we don't execute a class. What do we execute? An application. Okay, fine. It's the application which is executed. Class is simply a type. Fine. Okay, now to execute an application, what is needed? And this is clear. Compilation, javac, name of the file which contains my Java code. That code would have only one of those 4 things, right? Okay. It's nothing but a, so in this case we have given a class definition. You could have even used an interface definition. We'll see those examples also. Fine, that's clear. Okay. Now to run, now once you have this output which is a class file, to run, this is what contains my bytecode. This is what contains my application. The main method is in this, right? So when I want to run, I'll simply say Java and name of the class. I'm not giving name of a file, I'm giving name of a class. Name of a type basically. Java with hello world. Fine, don't give dot class or anything here. Name of the class. When I give name of a class, what will it do? When I say Java and hello world, what will it do? The Java runtime looks for a class definition for hello world. It finds whether I can see hello world, there's a class file for it. Okay, I can load it, loads a class file, looks if it has a main or not. Not every class would have a main. String is also a class, system is also a class, they don't have a main. And not all classes would have a main. They are classes, they are data types. Class is a data type. Application is a separate thing. Fine, but application still needs to go in one of those 4 places, or one of the 3 places now. And earlier only 2 places. Fine. Okay, but from Java 8, even interface can have a main. So when you give this name, just it loads this class, looks if it has an application. Looking for application means, does it have a method by the name of main, and is it static, is it returning void, is it public, does it have a parameter of type string array? If it has, okay, I need to invoke that method. What is needed as input to invoke the method main? What's needed to invoke this method? What's the input to this? String array. So it creates a string array. When I say Java and this, it would have, it locates, yes, there is a main, but then it has to create a string array. It creates a string array and then invokes a method. Oh, from where does it create a string array? It creates a string array. Arrays have elements. Number of elements will be there for the array. In this case, if we have given the command like this, the array is created with 0 elements. The array is created with 0 elements, and then this method is invoked. So array of size 0. Okay, if I had given the command as Java, let me rewrite here, hello world, fine, and if I said okay, suppose I write like this as my command, what would be done? Yeah, it locates, it loads this. Does it have an application? Oh, it has. I need to pass a string array. It creates a string array with size 3. The string array which will be created is from the command line. Those command line arguments, whatever you are giving, is used for creating an array, and that is the input to the main. Okay, fine. See, one could have modified this program, okay, and I'll write just the main part. Okay, it's like, or fine, in that same Java file, or okay, we can have another application now. Okay, we can write. I'll switch to writing the code straight away. Fine, I'll write a code and okay, let me show it fine rather than on the board. Fine, so let's write the code in a, fine, so you can use any simple editor here. Okay, so we want to have a class called hello world. And return the code as out.printf and send expression. Okay, this is what was the earlier code. Fine, let me show by compiling it. Let's see the output of all this. Okay, so I want to save this. What I have done here is I have created one folder for Java 1701, that's for our batch. Okay, I'll create separate folders. I'll create a folder called src where I'll keep all my source code. Okay, and I also have one more folder I'm using, and that's where I'm going to save, but I'm still creating one more folder here called bin. I don't want the class files and Java files to be at the same place. We'll manage them separately. Find source code in src. All my binary files, the compile code will be in bin folder. Okay, let me, here I'm currently going to save this. So let me go to src. Okay, in src, I'm going to save it as, yeah, hello.java. Saved as hello.java. And let's use our, okay, the src folder. And hello.java is there. So to compile, we use Java C, but now I'm using some switch here because I want the compilation, output of compilation to go in the bin folder, not here. Fine, directly put it in the bin folder. So we have the option of using -d. -d for destination. Destination folder is bin. So from the current folder dot dot is going to the parent slash bin. So this is the switch I used for specifying that destination is bin. Okay, class file, put it there. Okay, output of compilation should be there, and the file to be compiled is right. We'll use this command. It compiles successfully. Okay, so if you want, we can have a look at the it was in Java 1701. Fine. That's where we had the source code. Okay, and we have a class file created with that coffee cup. Yeah, you know what that coffee cup is. Okay, fine. Now to execute. Fine. To execute this, command is Java. But then if I just say hello world, it's in bin folder, it's not here. So the option here is to use minus, you can use -cp. So you don't need to change the directory and go to bin and then come back here while for compilation. You can just stay in the src folder all the time. Use the switch as -cp. -cp stands for class path. Class path. The path from where classes can be loaded. You will find classes here. That's what you are telling the runtime. Okay. If you want to look for classes, look them in a particular folder. I'm saying for classes, go to the bin folder is where my classes are available. Okay. And then hello world. And that's a class. And it says hello world. Okay. And I can use it doesn't change because yeah, we have simply said hello world, print hello world. Fine. Let's use those command line arguments now. Okay. Now another change I'm going to make. There are two changes I'm going to do. Java file. I'm already having one class definition. Let me also put an interface in this. Okay. Fine. To define interface, keyword is interface. Interface. Let's call it as hello interface. To put a main. Any parameter name could be used. I can use that again. And say it's going in the same file. There's only one Java file, right? What contains definition for a class as well as a interface. An interface containing the application. And that two applications now. Same Java file. Okay. I'm saying system.out. Now we have used printf. There's another one called println. And I'll use println here. Okay. And I'm saying hello world. I don't have to say backslash n. Println means with a new line at the end. Print with new line. Okay. Printf is print formatted of C, right? Similar to C, where you can actually have first parameter as a string and followed by any number of parameters. Right? You use that percentage %d and percentage %s, all those things. So that's the thing. It's the same. Okay. So println is different. Println is only one argument, always. So I'm saying hello world, or okay, to make a difference, let's put it as hello interface. And now let me try to use a command line arguments. Okay. In ln, I'm saying a dot a is my input parameter. It's an array. You can know the number of elements in the array by using any array variable, array of any type. Dot length will tell you the number of elements in the array. Okay, fine. This one, and then I can have a for loop. For in I equals I less than a dot, and I can say plus a of I. Okay. Plus is for string concatenation. Fine. AI is a string type. A is array of strings, so AI is a string. Okay. So string concatenation is being done, and that's it. And we can save this file. Save this. Let's compile this. Okay. If you compile, to the bin, two class files. Fine, there are two class files here. Okay. SRC is only one. And then this, there's no F8, right? Interface. Okay. We can have without parameters first, let's say. No command line arguments. 0. And says hello to each one. Clear? Command line arguments. Passing command line arguments, using them in an application. Okay. I want to say hello to James first line. Two. I want to have one. Fine, clear? Command line arguments, double quotes. Okay, fine. And just to complete the things, and we have understood things like Java file can have how to define a class. The most simplest form. There are other options like you can say public, the other things, abstract, and so many other modifiers are available. We are not using any of them. It's just simply writing, okay, I want to have a class name. That is used for defining a class. Interface, name of interface name. That's used for defining a interface. Fine. I want to define a enum. Okay, just go through all the 4 things. Okay. Fine. See how to define and everything. The full syntaxes will come later. Detailed things. And this is just first cut at okay. All the 4 types I want to have. Right. How do I define all the 4 things? So you can even define a enum. So for defining enum, name of the enum is hello enum. Let's call it as hello enum. Okay, this also wants to have. Now in case of enum, I had mentioned one thing. There is definition, definitely a definition just like a class. But along with the class definition, we have predefined objects. So it always starts with basically the object list. Okay, so between the object list and the definition, there is one delimiter of semicolon. So I am saying my object list is empty. I can keep my empty object list, put a semicolon to end the object list. Okay, before this semicolon, I could actually mention the objects which I would like to have here. In this definition, here I could have put some object names. I'm saying no objects. Okay, so object list is empty. So enum definition has an object list, a semicolon, and then the definition starts. Okay, fine. I'll just put a copy paste. Here. Yeah, that's the definition part. This part is list, object list. This is blank. And no need even to have a blank line, I'll just put it there. Okay, and I could have just gone with this. Okay. Instead of printf, you want to have a println. And enum. That's also okay. We can compile this. Let me clear the screen. Compiling hello.java compiles. You can see, right? Everything which you define as a class file of its own. Fine. Okay, and to run this, which one you want to run? It's like which one you want to run? Hello. Oh, we can go for a annotation definition, though we can't have application here. Fine. We can see what's the effect of trying to have an application in this. We can define how to define enum, the syntax part. Bare minimum, okay, it's not the full thing. Okay, bare minimum. If I want to define an annotation, annotation, there's nothing inside it. Blank. It's still an annotation. Okay. If I compile, yeah, that should compile. Good things. Okay. Someone says, let's try putting the application here. Let's try. Save this. Let's give it to the compiler. The first one, what's the first one? Static not allowed here. And that's the reason, like it's because we are saying static. Okay. And I can get rid of this. Semicolon here. Oh, I need to get rid of static also. And it can be void also. It will give errors. Want to see those errors? Till we get without errors? Okay. Keep getting errors here. Error. Oh. You can't have parameters for the methods here. Annotation does have methods, but no parameters. It can't be static, can't have parameters. Okay. Let's remove parameter. If it's complaining for parameters, let's remove it. Okay, no parameters, but then again another one, void. Even void, you should have some type basically. It can't be void. Okay, let me have maybe int or string or any such thing I can have. Int. That's also fine. There's a valid annotation which I have created. Something that compiles. I have created something that compiles. Okay, but that's an annotation. The rules for annotations, they are different from all other things. Okay, but yeah, that's our first Java code. And the first Java file which we have, 4 things go in a Java file. Okay, fine. We are initially going to be looking more into this, and then quickly we'll look into this interface. We'll be going into enum also. Fine. Want to use annotation somewhere? Okay, I think that you can. Is this clear? What? Clear about what goes in a Java file and what is a Java application? Application is main, but classes are data types. All these 4 are data types. Okay, but still somewhere you need to have an application, and therefore we had a main method going somewhere. But it's more about types. We'll be concentrating more on using classes as data types rather than as a placeholder for an application. These are placeholders for my application. You can look at it. It's just some place where I can put my application. This is the application. I need to put it somewhere. And they become the placeholders for the application. Those 3 things can be used as placeholder for an application. But more important is not the application. More important is creating the data types. Look at them as data types. Fine. That's where we have more of object orientedness. Fine. As far as Java 8 is concerned, the new things in Java 8 is pointing towards functional programming. It's not only object oriented programming. Fine. What Java 8 has done is it has done a fusion of functional programming into this Java programming language. It fuses functional programming into it. You'll see how we look at things as functions. When we say functional programming, it is about, we understand function. Meaning of function is some processing unit, fine, which would have a return type. It would have a inputs, does some processing, that kind of a unit. So you can have, you can play with functions in functional programming. You return what? What do we return? We return data. Till now we have been returning some data. You say return, oh, I have to return some data. Return type has to be a data only. Your parameters can be data. But here You could be passing functions as parameters. You could be returning functions. You say return and write a function there and say, okay, I'm returning a function. And the way you use data, and similarly you'll be using functions here. And that's where the functional programming is. See, I'll give an example where functional programming can, a very simple example of functional programming. You might have a class for account, which is a bank account. Now, bank account, whenever you do a withdrawal, it checks if there is some minimum balance which is required. It will allow you to draw even if you fall below the minimum balance. But when you do that, it will deduct some penalty amount. But how is the penalty deducted? It could be a function. Okay? It could be a function. It's a function of what's the current balance, what's the balance which it has gone to, and what is the minimum balance required. The difference between them and some such function could be there, right? Fine. And so it is basically a function and not necessarily a fixed value or something. So you would like to say, oh, let me set the penalty as that function. You want to have a function. Fine. Someone says, get me what's the penalty being used. Okay, it says, I'm returning this function which can be used for the penalty. And the concept is like that. Many places you'll have functions. You want to change the function which is working for penalty, right? Okay, so those kind of concepts will be there. Functional programming will be on those lines. Okay, so we'll be seeing that also, Java 8, right? Okay, fine. So tomorrow you have this exercise. You all have to do this. Okay, I'll be creating a repository for whatever code we are doing here. So you should be able to see this also. Fine, I'll put a repository. So yeah, you may not have used it, but I'll advise you to create an account on gitlab.com. Just open an account on gitlab.com. Okay, I have an account there. I'll create a project where I put for our batch whatever code is being created, that I'll put there, and then I'll push it to the repository. Fine, daily I'll keep on whatever changes we make, we'll have them available there. And so code will be available from gitlab.com. Fine, we'll have one project for our batch, Java 1701. Our batch is Java 1701. Okay, fine, I'll create that. And the lecture, whatever I'm doing, right? I'll basically we have this option of, and this is a live class. Basically the option is a live class, so which is accessible from eggheads.com. Okay, so you can even create an account there. Fine, eggheads.com. Okay, I won't advise, there's only one seat which is available currently. So if someone is not fine, only in emergency, you can attend from your home also. Okay, that would be available. Fine, that option is there, but don't use that option as far as possible. It's just for emergencies only. Fine. But anyway, I'll make this recording available. Fine. We do the recording. Yeah. It's a recording of a board, okay? Nothing there. Fine. Audio and board that's being recorded. Okay. So tomorrow I think we'll have that practical, right?